Hi, my YouTube friends. Just a short warning not to connect an older PA like this here, an old Kenwood TL9 2020, to a modern radio, simply because you could kill potentially your modern radio with one of these older PAs. I just wanted to give you briefly an overview how it hangs together, why you should not directly connect an older PA. Also, those PAs are very valuable, so that is really nice stuff. But in the past, the circuit designs in our PAs and of course in the older radios are different to what we have today. So if you directly connect a new radio to an old PA, yes, that can go wrong. That you get a better idea what I'm talking about, I have here a little drawing, and we have our radio, we have our power amplifier, and that is what you all know. So we have our HF out in PA. We have our HF in, and of course we have an antenna, and therefore we have a PA out, which will then operate with high power our antenna, if you like. Now, if you key your radio, our PA does not automatically go into transmit. So therefore you need a control line, right? And this control line is here between our radio and our PA. So that is most of the time cinch wiring. And if you key your radio, in your radio, while you key your radio with the PTT, the radio is pulling this control line to ground, and that means that our PA will switch into transmit, and you will get the full power of the PA to the antenna and those to air. So briefly, in our radio we have something like this here. So there may be a relay, and if you press your PTT, a little relay will switch a contact in your radio and switch this contact to ground. On the other side we have our PA, and in our PA we have a relay as well, and if you pull this relay to ground, then our PA will go to transmit, right? Therefore, of course, this relay here is connected to a DC operating voltage. And in older PAs, it is very often a very high voltage. So in our case, it is approximately 115 volt DC. And if we operate it, we have 33 milliamps. And that is critical if on this side there is a modern radio which will very often have only a very tiny relay which is not able to take high voltage, high current. Because if you switch 115 volt and 33 milliamps, or maybe a little bit more, then potentially you will create sparks here at that relay, and that might come to the point where these contacts burn together and it won't work any longer. And therefore, in this case, you really need to convert what we have here, that you get a lower current which is not really able to burn your contacts in a modern radio. But now let's have a look how it is all in reality. So you already see here, there is the marking RL control. So that is a relay control for transmit, right? And here at the back side of our PA, you can see here our RL control panel, which we need to contact to our radio to set our PA into transmit, right? Okay, now you can see that I have here connect some probes to get real figures out of our PA, that we can see if what I've told you concerning the voltage and the current which is present here at this terminal is really the truth. Alright, so the PA is switched on, so you may already hear the fan here. And well, so now we see that we have at our terminal millivolts, so no problem whatsoever. But it is now switched to standby, so you know you have two positions, standby and operating. Standby means that your signal from your radio is simply switched through, right? But when you then set it to operate, then the PA gets in between and will amplify the power from the radio. Okay, and that is what I'm doing now. I'm switching now the PA to operate. Here it is. And what we clearly see is that we really have 114 volt at this terminal, and that is not really low, so we could potentially damage parts in our radio. But let's see what happens if I set it in transmit. So when I pull it to ground, because as we have seen it here on my little drawing, where you have seen that we set the relay, which is here in the PA, will be connected or set to ground. So let's see what that means. Therefore, I pull here my plus wire and I set my meter to amps, DC amps, okay? And now what I'm doing is I'm really connected now over my amp meter, and let's see what it means. And that is what's happening. So now I do not know if you have heard the relay clicking in the PA, but now the PA is switched to transmit. You see here the 33 milliamps at 115 volt, right? And that is something what could potentially spark in your modern radio and really kill the circuit in your modern radio. So therefore, never directly connect a PA to a radio. Just always check out what the documentation of your PA and the documentation, the manual of your radio is telling you, so otherwise you might get in trouble. Okay, and for that purpose I have here a little converter circuit, a little converter module, or whatever you want to call it, and that is able to reduce the DC current which will operate with your radio. So if you reduce the 33 milliampere into the microamps area, then your modem radio is safe. And the circuit here is really so easy. That is all what you really need to do. So only some components, very easy to build, no problem whatsoever. Let's have a look into our circuit diagram to understand what I've done, and then we will have a look if it is really working and if it is doing what I've promised. And here we have it, the whole circuit, so simple and easy. So that kind of circuit is always used in any devices where you need to switch relays, right? So you simply put, as you can see it here, a switching transistor, you know, in the line, and that is what we have here. So we have here seen how it looks like, and if you put, you know, this little converter, right, to your PA, right, then it is quite easy. So this transistor will switch to ground, and it will get engaged by our ground signal, or by our ground switch in our radio. So that is what we have seen here, right? But because the working circuit, so that means where we have our 33 milliamps to operate this relay in our PA, will really take this 33 milliamps. And here on our control line connected here to the base, there we will only have approximately 250 microamps. And 250 microamps are not harmful to the contacts of you know, a relay in a modern radio, and that will not burn it, and that will not destroy it. So therefore your modem radio is completely safe. And you see here all the ratings I have done. So you see here that we have here a diode. It is a normal diode, 1N4007. We have here a capacity 10 nanofarad, 150 volt. So you need to observe here, you know, the voltage rating. So that is very important. And you can see here this little, I don't know if you can see. So my capacitors here inside have 500 volt rating. So that is more than good, and therefore that is what you need to do. And I've put here in the operating line as well a little capacitor. It is the same rating, 10 nanofarad, 150 volt. And I've here in the base circuit from the transistor, I have a 10 kilo ohm resistor, and that is then directly connected here, what we have seen here, to the terminal at the radio, right? And there we pull the base to ground over our relay in the radio, and then this transistor gets engaged, and now the relay here in our PA will get in operation, and will set the PA to transmit. So that is you know, the whole secret. Very easy. So you can handle it very easily by yourself. And you see, you can all put it in a little housing like this without any problem. So you see down below, let me see if I can get it a little bit better into your view. So there is my transistor BD244 Delta, so that is the one with a higher voltage rating. So do not use normal BD244. And you see here the resistors and capacitors, and there you can see the diode, the 1N4007, which is a little protection circuit, and that is all you need to do. Very, very easy. A little housing here, and that is all what it is. Alright, everything is connected in the same manner as we have seen it before, without the converter, right? And now we try to operate the radio over the PA without the amplification, and then we want to check it with the amplification of our PA. So let's see how it works. Radio sits on the 20-meter band, and I have adjusted it to 53 watt drive power, exciter power. And now when I press the PTT, so let me go back here. Now when I press the PTT, then of course we will work through our amplifier, and we can see the output power here at our meter at my dummy load, 1.2 kilowatt dummy load. Right, so now I key simply my radio. Oh, I have to switch on my cooling here for my dummy load. So now it's a little bit louder, sorry for that. But now you can see that it is approximately our, I hope you can see it. Let me double check it. If you can see it. Right, so here we have 100 watt and the needle is here in between. So that is, you know, the 50 watt power of the radio operating through our PA, which without engaging our PA, okay? And now we are doing here exactly the same what we have done before. So we engage here our amplifier. I have to do it manually because I do not have this system wiring what I need for a Yaesu, so that is not here, but it is here only to show how it works in principle, right? So no problem whatsoever. Now I take here again my wiring, and now you may have heard the relay clicking, and that is what we need. So what you see, we have 234 microamps, right? So that is now the difference. So now here on the radio side for your modern radio, we only operating with 233 microamps and not 33 milliamps, which could potentially kill your modern radio. So you see it is switching once again. You may have heard the relay, okay? And now let's see what it means when we key our radio now. Right, so the radio is set to FM so that I have a permanent carrier, so that is easier for demonstration. But we still have the same output power from the radio, only 50 watt approximately. And you have seen with our converter circuit, we have engaged the PA. Now the PA will amplify our 53 watt. And let's see what will happening if I press PTT now. So now PTT. And here we have it. With only 53 watt coming from the radio, now we have 1.1 kilowatt output from our radio, right? So very, very nice. That is great. Well, there's still one point which needs to be considered. In some new radios you do not have relays for this control line. So sometimes in new radios you have solid state transistors, and if you have solid state transistors, even it is very seldom, you may need to design a different converter circuit, right? Because 115 volt might kill your little transistor if a transistor is used in your radio. So always check the schematic of your radio to be sure that there is a relay in between to be able to operate this 115 volt. So that is very important. But as I said, that is very seldom, and in 95% even really new radios, maybe the ICOM IC7300 does have a relay which is able to operate together with this little converter circuit, but even the IC7300 should not operate it directly into here our PA. So therefore it does not happen very often that a modern radio only have solid state transistor in between, because you know, these transistors only have a lower breakthrough voltage, and therefore you need to be careful not to kill it. But well, as I said, very seldom. Okay, so that's it. Hope that was a little bit interesting, and I hope you know how to handle those questions if you come across. Okay, that's it for the moment, and see you later. Bye.